In today's episode of Chemistry Made Simple, we will construct a scheme where we have carbon, nitrogen and oxygen as elements, and we will ask the question, how many bonds do those elements typically have? From carbon, we know CH4 is a stable molecule, the methane molecule. For nitrogen, with hydrogen as bonding partner, it has 3 hydrogens and 1 free electron pair. Ammonia is a typical molecule, and oxygen has typically 2 bonds, and water is the standard molecule. We now can ask the question, do also molecules exist with 1 bond, 2 bonds, 3 bonds, 4 bonds for all those elements? And let us start with oxygen and for molecules with only 1 bond. Well, of course, we know there is the hydroxyl anion, which exists in equilibrium in water, in equilibrium with a 3-bonded oxygen, which is a cation. So hydroxyl and anion and a hydronium cation exist in equilibrium with water. In addition, well, there is also a radical known, the hydroxyl radical, for instance, generated by the breaking the bond of the weak bond of hydrogen peroxide at elevated temperatures, for instance. Well, let us go to nitrogen. Here, a 2-bonded nitrogen is this anion, an amide anion, for instance, with potassium as counter cation. For methane, let's skip 1 bond, then we are at a CH3 group, and indeed with a free electron pair we have the methyl anion. Let's take another electron away, then we have the methyl radical, also a well-known reactive intermediate. If we take away another electron, then we are at the methyl cation, 3 bonded carbon cations with 3 bonds are very well established as long as there is some stabilization effect. With just 3 hydrogens, this is not very good stabilized. Let's put that in brackets. This molecule might be detected in a matrix at minus 200 somewhat degrees. 4-bonded nitrogen, let's add another hydrogen to it, a proton, protonate ammonia, then we get an ammonium cation. This is a well-known, rather stable cation. Adding another proton to this hydronium cation, that won't work, since oxygen is a highly electrophilic element, and an oxygen cation will not allow the remaining electron pair to take part in some further chemistry. So, no, nothing here. Let's go to carbon with 2 bonds. Yes, this is known. CH2, it's a so-called carbene. The sort which has a free electron pair, and another sort which has 2 radicalic electrons in 2 different orbitals. Similar to a carbene, this is so-called nitrene, also a highly reactive intermediate. What about the CH molecule? Does this exist? Oh yes, it does. Between stars, astronomers have detected this molecule in outer space. And again, in a matrix at very low temperature, this can also be generated and detected. Thanks for listening.